Hey everyone, welcome to Data Science in Everyday Life. In this video, you're going to learn about how to use vector databases as stores to do the retrieval for your LLM queries, and in particular, using Pinecone as a vector database. Um, and the basic workflow is as follows. You have a few input documents, you want to embed these documents, and then you want to store in a vector database. Um, and the way you would store this in the vector database is you would create that vector database and then index it and upsert those documents. And then you would query it for retrieval, let's say in a process like retrieval augmented generation or RAG, where retrieval is an important component. So, before all of this, let me tell you a little bit about vector embeddings and why they're so important. This is a very simple example. Um, and the basic idea here is that the data is images, and you're taking very complex images and you're squishing them down into a smaller number of dimensions. In this case, you have two dimensions. One of them is size, so from small to big, and the other dimension is type of animal or living entity. So going from a tree to an animal, right? So if you have this picture, this can be dimensionalized here as a small animal. This elephant is a big animal. This large tree is a big tree. And then this small tree is in the small tree lower left dimension, right? So now you can imagine doing the same thing with text. Here in this case, you have four different bits of text, and as you can see, they're basically representative of the four dimensions. And then now, let's say you want to try and ask a query about it. You can use various dimensionalities. Like one, for example, is the sentence transformer embeddings that has 384 dimensions, um, and they're derived from the model BERT. So if you were to store this in a vector database and you can try and ask the question, tell me about a big tree, and it'll retrieve the most relevant document, which in this case would be this one here. During yesterday's storm, a large tree fell on the road, right? And the reason this is useful for LLMs is through RAG, or retrieval augmented generation, you can get this retrieved context, and then you can pass it through the LLM. And then in this case, I'm passing all the four documents, and you'll get a nice, rich answer. Basically, here it's, on the top, it's ChatGPT is answering the question based on the context that's provided. It talks about a big tree, defines a big tree, and then it talks about the various scenarios that I mentioned. Yeah, and you can imagine this being very useful if you wanted to do things like question answering over documents and financial document extraction, various things like that. Now, this is uh, just a visual understanding of it. So, on the left would be your vector database, where you have document chunks um, at the first column containing a bunch of the text. And then you have these vector embeddings, right? So in this case, it's just four dimensional. And these are showing these embeddings for these dimensions. And then what you can do is you can ask a query. Let's say for query one, this is the most relevant document. And so it appends that. And then for query three, the Bandipur might be more relevant. And then so on and so forth, right? So now that you've seen all of this, let's go to Pinecone and how Pinecone can be used to retrieve documents and create vector databases. So first is to install the dependencies like I've done here. Um, and in this case, I'm going to be using the OpenAI embedding model, the default OpenAI embedding text embedding ADA 002 model. And then for the document to put in the vector database, I'm going to be looking at this Amazon financial earnings document. Next, I define this get embedding function. And essentially, what this does is given a certain text, it'll give you the embedding for that text. Next comes this these two important functions called tokenize and split into many. And basically, what they do is you need to predefine what chunk size you need to convert this document into multiple vector embeddings. So, with a chunk size of 100, this would mean that each document chunk is 100 or less. Um, and chunk size is a very important parameter. So these two functions basically enable you to split the document into chunks, and then tokenizes to get the number of tokens. Where tokens is basically three quarters of a word, and it is the format that the LLMs like data to be inputted in. And if you've noticed, you would see basically costs for models like GPT 3.5 or GPT 4 saying, you need few cents per thousand tokens, things like that. And that's what a token means in this case. It is approximately three quarters of a word. Once you're doing that, we can call the tokenizing of the text. And then as you can see, you get, like in this case, 200 rows, in each row having 73 tokens and 62 tokens, so on and so forth. Um, and then we basically define these vector embeddings. Um, and then once we've done that, we instantiate our Pinecone vector database. Um, and then we basically call a batch generator. And this one, makes chunks out of an input data frame. But we're not going to be using it right now because so Pinecone likes to be given data in batches, and then this can be pretty important. Let's say if for some reason the process fails, you know exactly what batch you've stopped at, right? So in this case, it's not really doing anything because we just have 200 rows. But let's just keep this batch generator function right here, which is provided by Pinecone. Next is to upsert this into the database and create the index that you can do here. I'm basically sending the ID, which is just a placeholder, and then the content vectors here, right? Um, and also you can see the stats here. So the embedding ADA002 model from OpenAI has a dimensionality of 1536. You can see that here, and there's the vector count is also 200, so that's exactly matching what we want to send, right? The next thing that we need to do is we need to map these vector IDs in the vector database to the data from text, right? Because ultimately you want to be able to get the text corresponding to the closest embeddings. Um, in this case, what we do is we define this function called query article. And here, the parameters are the query that you're passing in, and another parameter is the top k. Top k here means the top number of relevant contexts that you're going to return. And typically, top k is 3 or 5 or something like that. Um, Once we do that, we can now query using this query output function. So here you can see I'm asking a query of how did Amazon do, and I want to retrieve the top 5, right? Um, so here you see most similar results to how did Amazon do. This is one chunk that's retrieved. And as you can see, it's quite relevant, right? Continue to delight customers with convenient delivery options. Um, and so the similarity score is 0.85 here. The next one is the company builds new products and services um, in some into you know it also invents new ones that customers didn't know to make their lives or businesses better. So that has a slightly lower score. And as you can see, there are 5 scores because there are 5 retrieve contexts. Um, and yeah, this is doing pretty well, right? You can ask another question. Uh, in this case, it's reviews from Amazon, right? All right. So I hope this all gave you a decent understanding of vector databases and why they're important, and how Pinecone can help you create vector databases and index custom documents. All right. Thank you all so much for watching. Please like and subscribe, and I will see you all very soon on data science in everyday life. Bye.